Hello friends. So these days we are discussing about practical aspects or laboratory based measurements of air quality. So we have already discussed how to measure PM10, PM2.5, even how to carry out stack monitoring. Today we will see how to assess the indoor air quality using multi gas monitor, because nowadays indoor air quality is as important as ambient air quality, because most of the time we work in the indoors, and especially during corona period everyone was housed in their premises and inside their houses, whatever environment was there. So micro environments air quality has also affected our health issues or other issues. So if we talk about indoor air quality and assessment of indoor air quality using multi-gas monitor, then we will look into the introductory part, then what are the equipments or apparatus which are used for indoor air quality assessment. Then like this is particularly based on probe, sensor based measurement. So we will discuss about the probe also, and how to carry out monitoring, then how to maintain the probe so that there is no error in the measurements, what is the procedure we follow, then how to control the quality or how to assure the quality. Then we will see the video to operate this multi-gas monitor, and lastly we will conclude. So as you know, indoor air quality is very important because there are several sources inside the micro environments where we live, and they can contribute to deterioration of air quality which we are surrounded with, and they can also cause certain health issues or they can affect our comfort level. So we should monitor the indoor air quality also. Well, if we use the multi-gas monitor, so multi-gas monitor is basically sensor based monitor of different gases, and it can monitor 5 parameters like temperature or percent relative humidity, then the dew point or carbon monoxide and carbon dioxide. But there are some advanced probes also which can also monitor additional 3 compounds like VOCs, volatile organic compound, ozone and hydrogen sulfide. So these 3 can be added. So total 8 parameters can be measured by multi-gas monitor. Well, when we talk about the equipment, means different parts or components of the instrument, then we can see here one is probe, okay, and then this is handheld personal computer HPC, and adapter is there so that you can directly use with AC, otherwise batteries we can use for running this probe based monitoring. So this is the sensor based monitoring equipments, and this is IQ 410 probe which is used for the direct sense of 100. It is known as per their parameters handling. Then AC adapter is there as we have seen, and then software, this is the software which comes with the instrument. Basically this is Wolfsense 2018 version, and then Microsoft synchronization software is also needed along with the probe software, basically so that we can transfer data and we can deal with the data analysis. So if we talk about how to use this probe or sensor based equipment, so anywhere indoor environment you can take this probe and keep there for certain time. So it has certain reactions, and then it can give the reading of those particular components, whether it is gas concentration or humidity or temperature, etc. Plus it can record the data into this HPC handheld personal computer. So from there we can transfer to the desktop computer, and we keep this probe for certain period, because otherwise there is variation in the reading, and consequently we can take 3 or 4 readings and then we can take the average of it. Okay. Then how to maintain, or what is the requirement of the maintenance of the probe so that it gives better reading or reliable reading and does not give us the erroneous readings. First of all, we need to store those probes or sensors in a cool, dry and dust free environment. The temperature should be less than around 21 degrees Celsius, okay, 21.11 or so. Then if the probe is being stored for an extended period, then we should remove the batteries, otherwise it can damage its functioning. If the probe gets dirty, then we have to clean it, but it should be cleaned by damp wet cloth only. it should not be attempted to clean from the inside, otherwise it may get damaged. So, better give it to the manufacturer or their agents, they can clean it properly following the proper protocol and they can give it back to you. Otherwise, just clean from outside using damp wet cloth. Also, we need to avoid operating this sensor in direct sunlight, because otherwise it will influence the relative humidity reading. Those measurements may be very erratic in that case, and we should not immerse this probe into water, otherwise it will be damaged. And if there is some condensation formation then on the CO2 sensor especially, then readings may be very erratic. It may give different readings of the temperature as well as those sensor based readings. So, we need to keep it safe basically, and we should not also drop it. It should not be come across some vibrations, otherwise some damage may be there. So, we should keep it very safely, otherwise readings may not be reliable. Well, so how to do the monitoring, basically like carbon dioxide, and we know that carbon dioxide absorbs light at a very specific wavelength, where other gases do not absorb in that particular wavelength. So, the CO2 measurement is based on non-dispersive infrared spectroscopy in this particular equipment. But on the other hand, like carbon monoxide, so the diffusing of the carbon monoxide into this electrochemical sensor is either oxidized or reduced using at the sensing electrodes, and then it can coupled with the corresponding outer reaction at the other electrode. So, a current is generated basically at the two ends. So, according to that current generation and flow, the proportional amount is the carbon monoxide concentration. So, that relationship is there, and this sensor gives the reading based on that particular activity. If we talk about like percent relative humidity, so it is measured by either absorption or desorption methodology of the moisture by a thin polymeric film. So, the relative humidity changes, the this dielectric property of the film also changes. So, according the variation comes and concentration are measured. For temperature, basically we use the platinum element, which is quite robust to give readings about the temperature. So, this is the way different parameters are used. Then we need to take this data to this HPC, it goes through software and from HPC to the desktop computer. And if you look into this procedure, like this software gives different kind of windows. So, for example, it gives this toolbar button and the pull down button also. So, this has different kind of buttons where we can play with it to know what kind of parameters we are dealing with. Like pull down button, this pull down menu has like file, view, probe, similar to MS Office software, as you know, like Windows, Excel, etc. So, file can be used for management of different files, to open it or to export the file in terms of Excel or Word or whatever we need and whatever it applies to. Then view gives the readings, details and statistics of those data which we have collected, and probe gives whether it is active or it needs to be calibrated. So, the probe button is used for that particular purpose. Then log button is there to set up how readings will be logged into. Snapshots can be taken by manually or like that. Then help button is there, which can give you different topics, frequently asked topics, plus email, if we have certain queries we can email. So, those kind of facilities are there. Toolbar buttons has like log, stop, snapshot, all these buttons. So, this log is to start the time log previously which has been stored, and then stop button is to stop the that functioning or the reading. Snapshot can be taken manually, and all button gives all measurement data related to parameters which can be seen. So, all these statistics, notebook, locations, they have their own functioning which we can look into. Then this live mode operation is there, and through serial port adapter we use either using AC current or battery operation is also possible. Then we can use this tap on view button readings, and those units can also be changed depending upon what kind of unit we are needing the values into. Then if we log into this mode operation, basically then we can select the parameters, okay, according to the need, and we can also ensure which interval we need to have, like per minute or 15-minute, those kind of default value is 15 minutes. So, that kind of most of the cases we use 15 minutes, otherwise we can change it for per minute or depending upon the need of the data. Well, so this is the way this log data appears in columns form, and ultimately it can go to the Excel sheet basically. So, the data transfer takes place when we connect it with the desktop PC, and then this pop up menu is there to transfer the data, and the data is transferred, then it can be opened in Excel sheet or different kind of software basically. So, you can see these are the possibilities: transfer all, if we transfer all the data which are stored there, or transfer site specific data. So, those kind of facilities are there. Well, we need to do quality control, as I said, because certain protocol has to be followed, and calibration is very important, otherwise erroneous data will be collected. Sensors are very sensitive, so we need to calibrate them periodically. For example, 12 months for this relative humidity sensor needs that every 12 months it should be calibrated, and like CO or CO2 sensors, they need to be calibrated every 6 months. Okay, but better if you can calibrate more frequently, but these are the minimum time period. Similarly, temperature sensor needs to be calibrated every 2 years, it is more robust, but annual calibration is recommended basically. So, now we present a short video for you to give you a feeling that how this indoor air quality assessment is carried out by multi gas monitor, and this video has been recorded in air pollution laboratory of civil engineering department of IIT Roorkee. So, enjoy the video please.
Good afternoon, everyone. And in the series of this lab-based measurement lectures, so our next experiment is the monitoring of indoor air pollutants using the multi-gas monitor. So for that, we are using this probe, which is being provided by the Grey Wolf. So in this particular probe, okay, these sensors are there from which we are measuring the indoor air pollutants or gases, which are, for example, volatile or organic compounds, ozone, hydrogen sulfide, and carbon dioxide, carbon monoxide, etc. Okay. So this probe is attached with this tablet. So in this tablet, a software is being installed in this tablet, from which we are able to monitor the indoor air pollutants at various locations. So what we need to do, we simply need to just attach this probe in this particular tablet, and it at any locations. So in a particular indoor environment, if we are able to measure the gases, for example, at the ventilation corner or at the corner of the room or office or lab, in that particular sense, we simply need to, for example, I need to measure this at here. Okay, so we simply need to place here, and it will stabilize, and we will be getting the readings. Okay, so next I will tell you how we are taking the readings in this particular software. Okay, this is the tablet which is being provided with by the Grey Wolf, and a particular software is installed. You can see Wolf Sense 218 Lab and Wolf Sense PC. So these two software has been provided by the Grey Wolf company, and they are being installed in this tablet. So now I will connect the probe with this tablet using this USB cable. Okay, so now I have connected. Now what next we have to do? We have to open the first application, that is Wolf Sense 2018 Lab. Now you can see this is the similar like what we are using in the Windows laptop. The user interface is same. So this is the software of WolfSense. We will be observing the readings of different types of gases, and as I have connected this probe, it takes a little time to detect the probe. Okay, so after the probe is being detected, it takes some more times to get the probe to stabilize. Here you can see a small message is being showing there that this probe is stabilizing. So after the probe gets stabilized, we can see the different types of readings are there for different gases. Here we are seeing the different type of gases and parameters are being shown here. That is total volatile organic compounds, carbon monoxide, ozone, H2S, CO, and having some particular units. Okay, now we'll explain the different types of say toolbars which is being shown in this user interface. So in the upper side you can see this file, log, probe and view. So this is known as the pull down menu. So in the file you can see there's number of options available. You can open the documents, you can take down the notes of this particular experiment which you are performing, or else you can open the previous documents which you have earlier performed and edit documents and carry on your particular experiments. And next is the log. Log, here we are in this particular menu, we are filing the experiment. If I click log stopped. So after clicking on the start log, you can see you are having the three options, that is snap, trend and auto. The snap mode is for generally if you are getting the instant reading. Trend mode is for giving the particular time interval. So and auto mode is the same. The difference between trend and auto mode is that in trend mode user has to stop the readings, and auto mode user can define the particular time of readings. Next is the probe. In probe, you can select the different parameters. You can see we have selected the total volatile organic compounds, carbon dioxide, ozone, hydrogen sulfide, and also you can this select the dew point and all from this particular parameters menu. Okay. Also, you can change the units for different type of compounds. Different type of units are being available in this software, so you can change according to your requirements. Confirmed. Okay, then other options will be in the pro menu, like calibration of the device. You can calibrate the device for different kind of pollutants. And next menu is the view. View is the where we are viewing the live readings of the gases. So live readings are being available. And next, you can also select the parameters which I've already shown in the probe. Next, you can see the graph, sensor tips, nodes, minimum, maximum, average. So these types of features are available where you can visualize your readings and and take down the notes, and also you can see what is the minimum, maximum, average of your readings. So next is the this downside menu, that is known as a toolbar. So in toolbar you can see the live readings, you can see the logs, you can see a review. The logs is the same which I have explained in the tool this pull down menu, and then there is a review. So review, you can see the earlier recorded experiments you can visualize here. And next is the graph, notes, photos, minimum, average and audio. So graph will be showing tentative graph of your experiments which you are performing. You can take down some notes, or else photo is also there. You can take down the photo of a particular site, and minimum, maximum, average which I have already explained. And next is the audio. Audio mode is also available. If you want to just add a voice note for a particular experiment, then you can use this audio note. So in this process, in this manner, you can just monitor the different types of gases in the indoor air environment using this multi-gas monitor, which has been connected with this PC. So this is the complete kit for measuring the indoor air pollutants using multi-gas monitor provided by Grey Wolf. Thank you.
Well, so on the basis of this video, you can easily visualize how this instrument function and what are the ways to transfer the data and other issues. So in conclusion, we can say that indoor environment gas concentration in the micro environments we are living, because VOC concentration may be there or CO2 concentration may build up because of so many activities, right, in the indoor environment. So they can be monitored by this multi-gas monitor, and sensor based monitoring is there, and if we carry out proper monitoring and analysis, that then we can compare with the recommended values whether it is fine or not, and accordingly we can recommend some solutions if concentration is higher. So this is all for today. Thank you for your kind attention. These are the references where we have taken information from, and you can go through them if you want to know more information. So thanks again, and see you in the next lecture.